Hello again. It's lovely to see you here for another episode of the Bitcoin Tech Tales series. Our previous episode discussed the initial stages of creating a candidate block. Today, we will pause that and focus on the Merkle tree. As before, we will employ our fictional world to illustrate the concept. The Merkle tree is named after its inventor, Ralph Merkle. It is a valuable tool for summarizing and verifying the integrity of large datasets. We extensively used the hashing algorithm we explained in one of the previous episodes to calculate the Merkle tree. We named him Hasher, and you need to know his working principle if you want to understand this episode. The Merkle tree is a binary tree of data hashes. In our case, we place the leaves at the top and the root at the bottom. In this example, we use 64 input data items to compute their Merkle tree. To start, we need to generate the hash for each data item, and let's save them in the data item hash collector container. These hashes serve as tree leaves. To initiate the process, each hash is paired up and entered into its corresponding hasher, creating new hashes. These newly generated hashes are then paired up again and fed into their respective hashers, generating hashes again. This process persists until only a single hash remains, the root of the Merkle tree, which represents the input data's fingerprint. The result of all this hashing is the binary tree, which consists of the computed hashes and the root at the bottom. It is essential to understand that if only one of the input data at the top of the tree changes, its hash and the whole branch down to the root change, too. In Bitcoin, the Merkle tree root or digital fingerprint represents all transactions within a block. In addition, the Merkle tree root for all witness data is also generated. Merkle tree represents all transactions in the block and, therefore, also allows for a quick check to see if a specific transaction we are looking for is included in a block. That's all for today's episode. We explained the Merkle tree, commonly used to summarize and verify the integrity and consistency of large datasets. Join us for the next episode of the Bitcoin Tech Tales series, where we will introduce the first algorithm that controls Bitcoin issuance, before we continue constructing the candidate block in the episode after next. See you soon!